In today's episode of Agile Giants, I am thrilled to have two brilliant minds behind the paper that, if you've done any workshops with me, you've actually heard me talk about this, any workshops in Gen AI. The paper is TELeR, a general taxonomy for LLM prompts for benchmarking complex tasks. Joining us today are Santu and Dongji, both esteemed researchers with a wealth of experience in the field of computer science. Santu is an assistant professor at Auburn with a keen interest in the intersection of natural language processing and information retrieval. He also runs the BDI lab there. Alongside Santu, Dongji is an assistant professor at Gustavus Adolphus College, and he completed his PhD in the BDI lab under Santu's guidance. The paper that we're going to talk about and the taxonomy, again, it's this framework for designed to tackle the challenging benchmarking complex tasks with LLMs. But I've also encouraged a lot of people who do Gen AI workshops with me to think about this as a way to just think about the inputs that they're giving to these LLMs. Have they actually given the Gen AI systems enough information to actually give them good responses back? And it's been a really helpful framework for them. So really excited for you to meet the minds behind this paper. I really hope you enjoy this week's conversation on Agile Giants. So Santu, Dongji, thanks so much for joining me today. I'm going to ask each of you questions, but feel free to choose which of you kind of fields first and which of you kind of jumps in. But I really want this to be a conversation. I'm so excited to have you today. Maybe as a way to get started, if you could give a brief overview of the paper itself and some of the main objectives behind it.
All right. Thanks, Sean. I'll start. So the goal of this paper is to enable more systematic comparison across large language models when we study them in the context of complex tasks. So what I really mean is the definition that we actually propose in the paper for a complex task is it has to be a combination of multiple subtasks. So what I mean by that is, now there is some subjectivity to this definition, but the point is, for example, if you are just doing a sentiment classification, whether there is a positive sentiment or negative sentiment with a particular statement, you could argue that this is a simple task by saying, oh, I'm just looking for one label. But one could also argue like this is a complex task, given that you first need to look at what entities are associated with a particular sentence and what kind of actions are being taken. You need to look at all those cases, and you could say, like, based on this, if this happens, then I want this to be classified as this. So the definition of complex task is actually to some degree subjective, but what we assume for the definition of complex task is basically you have multiple subtasks as part of your task definition, and you are using large language models, which are essentially like really powerful text generation tools these days. You are going to use them. But then comes this question, because a complex task can be expressed in many, many different ways. So how can we define a taxonomy that people in general can follow and can establish a general guideline when you are referring to particular kinds of prompts or tasks you are defining and giving it to large language models, which will actually allow like better informed and fair comparison across large language models. So that's kind of the goal, which I saw as both me and Dongji saw as an opportunity, because large language models are so popular and there was not yet a well-defined taxonomy to this kind of studies. So that's the motivation of the paper.
Yes, I completely agree with Dr. Santu. So because we have seen like large language model obtain a huge success in different like natural language process tasks like text summarization and text generation in their traditional setting. But there's no, after checking the literatures, we didn't find like a benchmark to performing this performing the instruction of large language model on the IO-defined complex task, which Dr. Santu just introduced. What is a complex task in our define? So to address this issue, we propose this taxonomy that can be used to design the prompt. And this taxonomy can also help the NLP researchers to study and report their performance with different large language model and draw a more accurate conclusion. So that is our motivation in this case.
Yeah. So given the audience here, I think they're going to be more familiar and more kind of comfortable thinking about it in that second bucket, right? How do I kind of think about this complex task that I'm trying to accomplish? And just to kind of take the air out of the balloon, I think, the people who are listening to this, who are trying to use this for complex professional tasks, I think we can sort of bucket all of those as complex tasks. So this is a good framework for all of the work that you as a knowledge worker are thinking about collaborating with a large language model to achieve. But just to kind of frame the benchmarking part of this for a minute, and to help maybe make this real, I think every time, just as we're recording it, just this week, Google came out with a new LLM, right? And people get really excited about it. And it's like, well, how do I compare the Google LLM versus the OpenAI LLM versus Facebook's open source LLM, right? And this provides a way to sort of look at the interaction across those different LLMs in a benchmark. So that's the kind of the research goal of it. If that's fair, and you're nodding your head, so I'm going to go ahead and just assume that's a fair way to think about it. I think the thing that's interesting to me is this paper has been really well received, because I think it helps professionals and it helps knowledge workers. I'm curious, how did the idea come up to start working on this taxonomy? I don't know which one of you is better to start this, but I'd be curious kind of the origin story of this.
Yeah, so I can definitely start on this, because I clearly remember the day when we said, okay, we want to do something like this. So here is a task that we wanted to do, and it was more related to understanding news media bias. And they are kind of the way they report an event. So real world events are reported by humans, right? And we have the very popular news media across the US, and they have different political associations. So we were trying to analyze the way different news media from different political bias actually report a particular event. So now you can imagine a particular event happening, and Fox News is reporting that news, and also CNN is reporting that news. And you can easily see the facts will be there, but then they will have their own way of interpretation, kind of their own set of preferences put into the story, right? So what we wanted the LLM to perform is, let's compare these two narratives and see what is common between the two narratives, to better understand what are the related facts, maybe, right? Because both are reporting them. And then it's possible that there is some bias or preference or expression style that CNN is using that Fox News is not, right? So we wanted, so as you see now, this is a complex task. It makes sense as a complex task, because now we are asking the LLM to do multiple things based on these two narratives. We want a multi-perspective summary of the two narratives, but we have specific subtask that we want the LLM to do. For example, we want to find out what is the common information that is present in both CNN and Fox News. We want to see what is kind of a unique information or perspective that is put by each of Fox and CNN, right? And we also want to see if there is anything conflicting. People, when they are reporting, sometimes they have a different way to present information that kind of seems to be apparently conflicting with each other. Now, we want LLMs who look at these two narratives and kind of generate a summary by summarizing these three different constraints, overlap, the uniqueness of the information, and the conflicting part of those information, right? And then we said, okay, let's just try out the popular LLMs. So there was GPT, of course, and then there was Google Bard, and they had their PaLM language model, and then there was Bloom model, there was Llama from Facebook. And we kind of said, okay, we want to do this study systematically, and we immediately realized not the same prompt works the same way for different large language models. Now, you probably one prompt A works better for ChatGPT, but then prompt B works better for PaLM, right? Now, and then how do I make a comparison? So it's not fair that we give a prompt that is not optimized for PaLM, but it is optimized for ChatGPT, and then say, okay, ChatGPT is better, right? So in order to establish a fair benchmark and kind of like a systematic study as academicians, we do that, right? So and there was no taxonomy that is present, like, okay, what are many different ways you could prompt, because we have so many different complex tasks, and we could prompt each complex task in so many different ways, and the LLM's output is every time a little different.
Right.
Now, how do I establish a common benchmark that would make sense to me, rather, like, without requiring me to actually go to the entire set of prompts they actually did, which is a lot of time consuming process, right? And then often, and then the data is not public of the study, and the prompts that were used are not reported, right? So how do I establish a common benchmark that still gives us some idea to the level of details and kind of the properties of a prompt that was fed to multiple LLMs? And that's where we said, okay, we don't find anything in the literature. That's a bad news, but that's a good news as well, because now we can propose one, and
That's
we
right.
can claim, like, here is the first kind of taxonomy for you there. And it's a very general one. It applies to complex tasks in general. But then we could also think about extension of this particular taxonomy to specific use cases. And you can call it like TELeR safety,
Yeah.
TELeR security, and TELeR maybe news domain, or whatever you want to call it. So, but we have a very general framework, and that was the challenging part. Like, how do I even come up with such a general kind of taxonomy that can cover all LLMs, all kind of prompting ways, and all that?
Yep.
That's my side. But Dongji, do you remember anything else when we were actually like jotting this down?
Right, like Dr. Santu said, it was originally from another project that we are just focusing on design different prompt to evaluate like different large language model for that particular narrative summarization task. So initially, I was just create like different prompts with different details, levels of details. But because the intuition is like if you put more details to the prompt, that should enhance the effectiveness, right? That is just a like intuition. However, the concept of the taxonomy was not like considered at that point. So I discussed with Dr. Santu, and we raised a question mark, like, why don't we just categorize and cluster different like similar prompts together? And if the prompt is different in their different level of details, can we kind of like generally claim that is a fair comparison? So to give you a like illustration, like let's imagine you are riding a bike and I'm driving a car. Can I see, because my car is faster than you, it's just saying like car is better than a bike. It's maybe car is faster than bike, but that is not a fair comparison, right? So we want to compare the Porsche with maybe Tesla, and also compare the like, I don't know the bike, different bike,
Sure.
but like compare the things in the same
That's
ways, right? So that is the institution for this one.
Yeah, this is great. And you're getting actually some of my questions already, which is your answers, which is awesome. But Dongji, you actually started to go down this already with level of detail, right? That's one of the components of the taxonomy. But it's probably helpful to just quickly at this point say, like, let's walk through what are the components of the TELeR taxonomy.
Basically, all the details is in the paper, but I can quickly go through that. So the category of large language model prompt for the complex task along with like following 4 dimensions. The first one is the turn. So basically you want to interact with large language model with only single turn or like multiple turns. So that is the first dimension. The second one is expression way. So that is based on your expression style. If you are just trying to raise a question to the large language model, or you are trying to give some like direct instruction to the large language model. The third one is a role. So as that is based on like if you are providing a role of the large language model specifically, one interesting thing is recently people finding the ChatGPT is getting lazy because, and when people, some researchers are saying like, oh, because that is getting to the December, and ChatGPT trying to play as the students are have a winter break, so they're getting late. So that is a way to giving the role of this ChatGPT or large language models. So the last part is a level of details. So that is a degree of the details that we will provide to the in this prompt. So turn, expression, level of details, and roles gives our the name like TELeR
Right.
with the first characters.
Yeah, thanks, Dr.
That's right,
I
Santu?
would like to, yes, I'd like to like add some maybe some examples to all those 4 dimensions.
Perfect.
So the first one, when we call turn, is basically what it means is, a complex task has many subtasks and many requirements. We could mention all the subtasks in the single prompt, in a single shot, right? And give it to LLM and hope that it will do all of it. Or we could do one subtask at a time. And this kind of resembles the chain of thought process, right? You kind of give one subtask to a student or to a child, and they kind of go through it, and then you again ask for something. So whatever you have done so far also plays a part when the LLM is actually trying to give you a response. If you do it in a multi-turn fashion, because now there is a chain of thought process, and whatever your response was previously is now part of deciding what you are going to do next, which doesn't come with a single turn. Then the second part of our taxonomy is the expression style. So you could kind of, because we are using LLMs to do some task, we can ask this to ask them to do that task in primarily 2 different ways. One is like an instruction, a command, right? So you can say, okay, please write a summary based on the following text, right? Or you could ask it in a question style, and not always that they will make a huge difference, but sometimes they do. You could ask like, can you write a summary for the following text? And based on the way you are asking, the LLM's response will also be different, because they have been heavily tuned over like instruction tuning paradigm, right? So the third level is the details level, and that's where things get the most interesting, right? And we have like kind of like a different layers from 0 to 6, which is like right now the 7 layers of like taxonomy in the revised version, where we kind of, you can say, incrementally increase the complexity of the and the details of the prompt. And there are specific levels. If you are more interested, you can go into the paper. And the 4th dimension is basically the role. So it often helps. For example, in ChatGPT, when you are using their API, you can define a role. For example, maybe you are a medical assistant trying to serve some patients, and in that case, the ChatGPT will try to prioritize knowledge from the medical literature rather than the social media, because you want to be more factual when you are dealing with like medical application and so on, right? And maybe if you define ChatGPT to be like a writer, then it's fine for ChatGPT to be more, let's say, imaginative, right? More crazy. And you can define those roles to actually kind of set hyperparameters that can be fine-tuned or like empirically set inside ChatGPT to actually behave in many different ways. And that's what gives you some control over how you want the large language models to behave. We understand this is not it. I mean, this is not the end. This is just the beginning, and this prompt has to evolve. But we had to start somewhere that is general enough, and that's where, like, we have this TELeR taxonomy at this stage. But yeah, we are happy that people find it, or people are already finding it useful, and then we can see many different extensions of this TELeR taxonomy to specific particular domains.
So I think this is great, and I would actually say, so we will include a link in the show notes to the paper. I would encourage all of you, right? So a theme that's been coming up all season is like, when you have a job or something you need to accomplish, think about how you can go and augment some of that work with going to ChatGPT, Google, whatever your favorite LLM is. I would encourage you to actually take the level of detail diagram that's in that chart, print it out, and just put it on your desk, because it is a really helpful way to think about what are the things that may be missing in this instruction that I'm giving the LLM to make it better. So these different levels of detail that you can go through. So level 0 is basically no detail. You're almost never going to do that. But you'll often find, I'm hovering at a level 1 or level 2. I'm not getting the results I want. Well, maybe some of these other things further down the taxonomy will be helpful. I think you did a really nice job there giving some examples. And I think the conversation so far has made it pretty obvious why this is useful for researchers. I know the BDI lab, a lot like the work we do at CSL at Carnegie Mellon, does a lot of work with industry partners as well. I thought it'd be interesting to talk about why you think this taxonomy is valuable from your industry interactions, in addition to the research stuff that we've already spoken about. So I don't know which of you wants to take that, but how do you think industry should be thinking about the work that you're doing?
Yeah, I can take a shot at it. So if you think about the future workforce and kind of the way AI is getting democratized, like over like in just every couple of months, right? The progress is so rapid, and everybody is thinking about, okay, given this speed of like technology, how the future workspace will look like. And my take on that is basically the future is definitely going to use a lot of generative AI, and it is definitely going to be some versions of conversational AI that gives you the most flexibility. Think about while you are cooking, you want to accomplish some task, you want to just like express in natural language that you see kind of in movies, right? Um, so in that sense, the more we can make the conversation natural and make our requirements of a task like more suitable, like for the machines, that's where this prompting technology. So you can think of this as uh, an interface between humans and large language models, because humans kind of have their own way of expressing things. It is not necessarily the best way you want to communicate with a machine. At the very beginning of computer science, the communication was like, okay, you have to encode everything in 0 and 1. Other than that, computer doesn't understand anything. We have evolved from that. And now then we had C programming. Then we evolved from that. We had Python, object-oriented programming, Java, and then we had SQL. We kind of made more progress and we went more natural, like over time. And then now the movement is more towards complete natural language understanding, and LLM is a big step towards that. But still, what natural language is optimal for what kind of prompts and like what kind of task is still not like well studied, right? So now, whenever as a practitioner in industry, you have some task where you are trying to use LLM and you are trying to do some task, right? The obvious question is, okay, let's say I'm a data scientist or even a prompt engineer, which is kind of a new role has emerged, right? You want to ask ChatGPT to do some particular task. The obvious question is, how many prompts you should try, how many prompts is enough, and what is the first prompt you should try, and then how you kind of decide that this is the like optimal prompt for my task. So there is no guideline right now that any practitioner can use. All they can do is kind of like start playing and come up with their own kind of set of interpretation and how the system is working. And there is often possible like you are missing on opportunities if there is no like specific systematic guideline. Okay, so you should try this first, level 0, level 1,
Right.
level 2. If it doesn't work, sometimes it also doesn't mean like going higher level will give you a like better accuracy for your task. It might be like, okay, level 4 is the optimal, but if you go to level 5, that is just like distracting LLM from for some obvious reason or for some obscure reason that we don't know. But at least you need a place as a data scientist or prompt engineer, you need a place where you can have a guideline. Okay, this is my task, and this is how I should like approach this task in terms of giving it particular prompt from the probably like a simplest way to a more complex way, because you don't want complex things unless you need them. So our prompt taxonomy can because it is so general, people from all kind of era like domains who are like using LLMs in one capacity or another, they could use our taxonomy to have a start and a gradual iteration of prompt revision that kind of optimizes their goal task. Dongji?
Yeah. Yeah, I think another two benefits for the individual users, such as like engineer or researchers. The first one is you can do increase the reproducibility of your prompt. And the second one is you can increase like communications with if you're using this prompt and you want to explain that with other engineers. So the reproducibility is very important, because if you just change your prompt a little bit, that will impact the performance of large language model. So our dimension, our defined for dimension is just like the attributes. So this is maybe if let's say you are create a class in the Python or the Java, you will put the attribute to this class, right? So if you change the attribute, that will change the performance of this class. So it's same things. If we like highlight these different attributes, that people will know, okay, if we change this, that will impact the like evaluate your performance in a better way, and also further do the explanation. So yeah, that is a true benefit for the individual users, and for the in the company wide, it is better for them to discuss with each other and generate a final conclusion about different problems.
Yeah, that's a good. The Java's a good analogy there. So let's I want to finish talking about kind of the future of the TELeR taxonomy, where you see that going. But before we get to that, let's kind of step up a level and let's talk a little bit about the lab that this originated within, right? So the BDI lab. Maybe could you talk just a minute about what the BDI lab is, and then some of the other projects that you have going on there?
All right. So if you think about the field of artificial intelligence, so how it evolved, that has to do something with with this naming thing. So AI has been there for a long time, and traditionally, interestingly, the AI community was not the core computing community, which you kind of today you might think like, oh, AI community must be a sub community with their computer science within. That's not true. The intelligence and kind of like artificial intelligence community used to be completely like very distinguished and separate from the computer science community. But then something magic happened, right? So over time, people realized that in order to do faster intelligence, you need computers, and computing capability like exponentially improved over time. And with that, people could see that we could use this increasing computation power to build powerful models that have been proposed by the AI community. But it's still at that point, at some point, people were not really seeing the impact of AI because we didn't have the data that we actually really needed to actually train all those AI models to really see their power. Now, what kind of techniques that you see today in like ChatGPT and Palm, Google Bard, Llama, it's not like a very complete novel like method or like architecture they're proposing. It's just the scale of the data and the models. So now, the time that I was kind of forming the BDI lab, which was around 2020. Now, the point was, at that point, there were many architecture proposed by these AI researchers, right? Neural networks, attention models, transformers, everything was there already. And but the scaling up of this chat GPT was not still there. But people knew that the more data we get, the more powerful, like massive the architectures become. We are seeing an increase in performance. That trend was there. So people kind of correlated the big data with the amount of actual actionable intelligence you can get. So there is a difference between AI model and actionable intelligence, right? So AI models are great and they have this learning capability, but then in order to like really have actionable intelligence that you can actually leverage and make decisions on, you need big data. And that's why I kind of tried to combine like big data and intelligence into a single thing. That was my kind of like research agenda when I started my lab. And then since then, we have been trying to.
So, and just because we've been saying BDI the whole time, so just BDI stands for, because I think this is a good point to actually give the.
Yes, so BDI stands for Big Data Intelligence.
Right.
So it's basically the intelligence you kind of actionable intelligence you can derive from big data.
Right. Okay.
Yes.
And so now give us a couple of these use cases that you're, or a couple of these projects that you're working on.
Right. So one of the projects I kind of already mentioned with you in terms of understanding multi-perspective narratives, right? Because this is how the TELeR taxonomy actually started.
Sure.
And this multi-perspective narrative understanding has been of interest to the DoD and intelligence community because they often deal with intelligence gathering. And there are multiple different versions of the narratives coming out from all over the world, from all different agents and all different like sources, right? Then how do they make sense of all those massive amount of information that is coming within a very short amount of time to actually convert them into actionable like items. Because if you are a human, and if I give you like the like 100 years, probably you can read all of them and make sense out of it. But then that problem no longer remains relevant, because we need to have actions in real time. So that's where our this multi-perspective narrative understanding can help users like see different perspectives of the same event expressed in different narratives and kind of make sense out of it. That is one of the major projects we are leading in our lab. The other like big project that we are running in our lab is, I call it like the virtual interactive data scientist. So think of this as more like, we call it VIDS, VIDS, virtual interactive data scientist. And think of it as, okay, let's say you are talking to this LLMs, right? Or you're talking to like more like product level assistants like Siri, Alexa, or Google Home. And then you want to say, okay, hey Siri, what is going to be the traffic in the city of Atlanta in the next couple of hours? So based on that, you could kind of try to predict which route you should be taking. Because right now, if you look at Google Maps, they do some projections, right? But now think about a data that is not public there, because traffic data is public or weather data is public. But then now think about your company. Let's say you are an airlines company and you have private like data for your flight delays and everything, right? So then you don't want to share that with like chat gpt and give it to OpenAI. Or if you are concerned about like
Right.
it contains sensitive data, you cannot just give it out. So then, given today's large language models, there is no way you can frame a data science problem without really knowing how PyTorch work or TensorFlow works. These are like machine learning platforms that people use for deep learning today, right? So not even I'm pretty sure like some of the audience who are listening here don't know how to like frame a TensorFlow pipeline, right? We don't expect that.
That's a safe assumption. Yeah,
Right.
that's a safe assumption.
We make that assumption. And yes, that is true. I want to make this distinction between AI enthusiast and AI expert, because AI experts are building those models and they know how it works. AI enthusiasts don't have to be an expert there. I don't need to teach them neural networks, but they are experts of their own domain. But I want them to be able to like benefit from these like massive power of big data and AI. So how we do that? Through a conversational agent that we are introducing this idea of conversational data science, where you talk to Siri or Alexa like they are your personal data scientist. Now think about this. They are not going to be very accurate and expert as an expert experienced data scientist, but it's free. It has no privacy risk, because we are going to give you the conversational agent on your local machine. You can take it and then you have a demo, and you can have a conversation with that conversational agent, and you can kind of in natural language you can express, okay, this is my data set, what my data set looks like, which is in your local machine, private, secure. And then you can express like, I want to predict how many flights are going to be delayed next week, so that I can make proper actions, and maybe which of the airports are going to like face those difficulties, so that we can better serve the customers, right? And then based on our framework, what we will do, our conversational agent will try to understand what the user's goal is and the data set, how it looks like, and try to create that training and testing data set and the objective functions, all the technicalities that takes place by a human data scientist. And once you can create those, you can always throw them to those existing automatic machine learning pipelines to actually execute those things and build a model and give you some predictions. So what we're trying to do is to give an abstraction between existing AutoML tools, which are this TensorFlow, PyTorch, and all, versus the humans. And our virtual interactive data scientist is actually a virtual data scientist that is having a conversation with you to understand your data science needs, convert them into a concrete machine learning task, and fit them to the AutoML pipeline that you can execute without even knowing how to do machine learning.
That's fascinating. And I was going to ask you for use cases, but you did a nice job sort of weaving the use cases into that answer. So that's great. Let's come back to the taxonomy here, though. So as we sort of move to a wrap up, where do you see the TELeR taxonomy going from here?
I think it's a more imaginative kind of way of answering this rather than like really like laying out what should be the direction. So as someone who has kind of initiated this, I want this to be used by practitioners and developers and as well as researchers as they see fit. So I would hate that the fact that I will kind of like propose the next kind of extension of this. Rather, what I would like to see is people kind of trying to see what are the limitations of this taxonomy. For example, once you take things to the real domain, right, then you will see, okay, I have this use case which is not covered in the TELeR taxonomy. For example, we revised our taxonomy. If you remember, our original paper had 6 taxonomies from 0 to 5. And now if you go to our archive version, now we have 6 different levels. What one extra levels that we introduce is the retrieval augmented prompting. What basically means is, let's say you are prompting ChatGPT something, and maybe that idea or knowledge is so new that ChatGPT has not been trained yet on that. So it doesn't have a clue what you were talking about. But if you kind of give some relevant content related to that and make it part of the prompt, maybe ChatGPT, based on their other embeddings, whatever numbers they have learned from like big data, they can make sense more and serve you better. So now this application came from another domain that I was trying to like apply and see, oh, retrieval augmented thing is a thing. And we don't have that in our taxonomy. So let's try to fit it into our taxonomy, right? So I kind of try to see the future of TELeR taxonomy as apply it and in many, many different ways as possible and find out with corner cases that TELeR taxonomy doesn't handle. And let's try to fit it into the TELeR taxonomy to make it more general, to make it robust, so that this becomes a general platform that everybody sees and kind of knows about, so that you don't have to explain every time what exact details of the prompt. You can just say, okay, I use TELeR taxonomy level 4 with system role defined in a question style, and that should be enough for people to relate to. Oh, you use that kind. Okay, makes sense. So that's where I'm seeing the future should be. People should be able to relate their prompts with a particular level and type of prompt from the taxonomies, so that it becomes like a practice standard across like researchers, practitioners, and developers. Dongji, you might have a different view. I don't know.
Right. I mean, soon after we submit this version to the archive, we saw many like computer science bloggers and who shared our paper on their like Twitters and or like any other social medias. Actually, I also found one Chinese blog who share the latest AI stuff techniques, post their paper on the Weibo, which is a Chinese social media, just like the Twitter. So the idea is we hope like more and more people to use it and trying to find the bug of it and fix it with us together. Just like how people trying to find the bug in ChatGPT and propose that, and that is a hot topic.
Now let's make it an open source project.
Right. Yeah.
Fantastic. Well, guys, this has been an amazing conversation. For everybody listening, I would encourage you to follow Santu and Dongji on social media. We'll make sure to include their socials in the show notes as well. But I guess for both of you, what are the best ways for people to stay aware of your ongoing projects?
You mean stay aware, right? Not stay away from us.
Did I say stay away? I'm sorry. Yes, stay aware. Wow.
Yeah.
Yes, stay aware of your projects. Thank you.
Right. So as researchers, we kind of like both of us have our own personal websites. That's definitely one place to go. We repeat kind of consistently tweet about our like progress in research. That's the other place, like following us on Twitter. In terms of, I often if there are papers and results that we have that I think will be very useful for practitioners, I often post them on LinkedIn. So maybe you can follow me as on LinkedIn as well. And we don't yet have a separate website for our BDI lab. I think we should be creating that. But I think the best way to keep updated is to keep following us on Twitter, on our website, and often like Auburn
LinkedIn.
University, where I'm working at the department, we have news that we also share. Yeah, that's pretty much it. Dongji, anything else I missed?
Yeah, I mean, I use my personal website to post most of my latest news in most of the time. And I also use LinkedIn to share my thoughts and my latest work. Yeah, so basically you can find everything about me from LinkedIn and my personal website, like Dongji Feng. So
Perfect. Okay, well, we will include those links for you to stay aware, not away, but stay aware of what they're doing. And guys, I really appreciate you taking the time today. This was a fascinating conversation. Again, I think many people have heard me refer to this TELeR taxonomy for the things that we've been doing, talking about generative AI in some of the different industry workshops that we've been doing. So it's great to be able to put the faces with the names and hear a little bit of the story behind it. So thanks for joining us today.
Thank you very much, Sean. I mean, as researchers who are working mostly in an academic setting, seeing that our work is actually impacting practitioners, industry people, like the real world, that's really big. And your platform, I hope, and I'm really grateful to you to give us this opportunity. And we hope that our impact and our voice will be like more reachable to the practitioners, and it will be more popularized, and people will be like more interested to use the TELeR taxonomy from now on. So thank you again very much, Dongji.
thank you, Sean. Yeah, it's my pleasure to share our thought with you and with like the audience that follow you. So thank you for this opportunity, and we will stay tuned and maybe talk with you later.
Awesome. Thanks, guys.